All right, let's try this again. I just made this video yesterday, and for some reason it didn't work. So I'm gonna go through it a little quicker. So if you need more explanation than what I'm gonna give in this video, go and check the practice problems, the extra practice problems that I made, because I made extra practice problems on these and on scientific notation. But these are all on this checkpoint 5A for exponents and scientific notation. So here we go. To do x to the fourth times x to the fifth, you simply add the powers and you get x to the ninth. Hopefully that's an easy one for you. For, I guess we'll go to this one. X to the third times x to the negative seventh. I'm going to add these powers and get x to the negative fourth, which is fine and dandy, but you cannot have negative exponents in your answer. No. So negative exponent just means flip it. So it's 1 over x to the positive fourth. All right. And then over here, the only thing that you need to do here is change this. This is a negative exponent, so move it to the bottom. We'll leave the 3y to the fifth on top. And x squared is to the bottom. Let me erase all this, get it out of the way. I'll just pull these up one by one, maybe. X to the sixth over x to the fourth. It's just x squared is the answer. Excuse me, but either visualize this. There's 4 of these on the bottom. Cancel, 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 cancel is x squared. Or you can use a shortcut. When it's a division problem like this, you simply subtract the powers. So it's x to the 6 minus 4, which is x squared. Okay. Same thing for the next one. No, don't be dancing. Get back up here. All right. Let's say you can do x to the 2 minus 7, which is x to the negative fifth, which is 1 over x to the positive fifth. That's one way to do it. I simply just think 7 minus 2 is 5, and I put the extra x's where they belong. There's a lot extra x's on the bottom, so that's how I kind of do that in my head. Or I guess it's kind of thinking this, but I don't actually visualize all the x's. 1, 2, 3, 4, 5, 6, 7, and then cancel, whatever. Cancel, cancel. There's 4, 5 extras on the bottom. And you have to have a placeholder on top. So whatever method you prefer, just get it right. And then, oh, here we go again. There we go. And then now this one's a little different because it's got the negative exponent on the bottom already. So what I would do is circle it and move it up to the top. So we have m cubed times m to the positive fourth now, because the negative means reciprocal. If it's already on the bottom, move it up. There's nothing left on the bottom, so it's just m to the 7th power. Okay? Next problems. With the powers, you simply multiply. So it's just x to the 8th power right here. Okay, versus if it was x to the 4th times x squared, that would be x to the 6th, because there's 2 separate bases. Single base, 2 powers, multiply. Here, same thing, multiply, so it's y to the negative 2nd. No negative exponents in your answer, so flip it, 1 over y to the positive 2nd. And let me get rid of that. Carefully. This is one problem. So whether it's, can I do this partially? Nope, it's one big group. Well, it's one problem. So you will see this written closer together for each other. So I would do each part separately like this. So 3 squared, x to the negative 4th. The 4 is not influenced by the negative 3. But then the negative 3 does go on these parts. So it's x to the negative 6th, y to the negative 3rd, like that. Okay. Then you need to multiply, this is 9. 3 squared is 9, not 6. 9 times 4 is 36. And then together, that's x to the negative 10th. So on the bottom, it's going to be x to the positive 10th. And then this moves to the bottom, so it's y to the positive 3rd on the bottom. Fine and dandy. And then this one, similar problem as this. Oh, I bet I was supposed to do these separately. Well, we just did it the hard way. Yeah, I think I think I meant to do this two separate ones. I better answer that phone. 1 second. All right, that was an interesting phone call. All right, back to the math. Yeah, so I think I meant when I made this to do these two separate problems, like that problem separate, but I just kind of grouped these as two problems together. But you get the idea. These are for sure together. So 2 cubed x cubed y to the sixth. Now the 4 is inside the parentheses, so the 4 is influenced by that power of 2. Like that. This is 8. This is 16. And 8 times 16 is 128. And then x to the ninth, y to the 10th. Just adding the powers. Fine and dandy. And then this one. When you have a problem like this, you can put the 2 on all these parts right away. You can put them in all 6 parts. But because these numbers are so big, and I don't want to reduce 18 squared or whatever and 24 squared and then reduce that later, I prefer to reduce ahead of time. So I'm going to ignore the 2 and put it on later. You can do it either way, but this is less chance for screwing up. So I'm going to reduce this, divide by 6, and divide this by 6. And then I'm going to reduce these two. I might as well just keep reducing. So I have 3 fourths. I have an extra x on the bottom. 2 on top, 3 on the bottom. Cancel, cancel. I have 3 extra y's on the bottom. Y, cancel, cancel. And then square it. Now don't forget about the square though. Now when I square the 3, I get 9. When I square the 4, I get 16. And then x squared y to the sixth. Then you don't have to reduce at the end, since we've already reduced ahead of time. That's pretty cool. I just want to throw one quick note in here just because it came up and, oh, shoot, I'll do that. I'll do it right now. A note on something like this, like 2x squared versus x plus 2 squared. Okay, these are not the same at all. Okay, so don't do them the same way. This one is 2 squared. This one is that answer. This is not x squared plus 4. Okay, you can't just simply put the 2 on both parts. What's different here is this plus sign. So this isn't this checkpoint, but it comes up in homework, and it's something that's really important. You need to think of this as x plus 2 times x plus 2, because it's squared. Two separate problems, and then like this. X times x is x squared. X times 2 is 2x. Then multiply the 2 times this one. And the 2 times 2 is 4. This turns out when you group these two together, x squared plus 4x plus 4. That's what you should get, not this. Okay, so these rules are, these shortcuts are nice and handy and everything, but don't transfer them to the addition ones because that's going to throw everything off later. All right, now to the scientific notation. When you multiply the two problems that look like they're in scientific notation, even though this one's not right here, because it's not between 1 and 10. This one is between 1 and 10. Simply multiply the numbers and then multiply these. So 98 times 8.95 in my head. I think it's 877.1. Yep. All right. And then, okay, I used a calculator. And then times 10 to the negative fifth power. I'm just adding 3 and negative 8. Okay, it's kind of like saying 2 times x squared times 4 times x to the fifth. I'm rearranging it. 2 times 4 times x squared times x to the fifth. I'm just rearranging stuff and putting them next to each other. So I can make that together and make that together. That's all I'm doing up here. I'm putting these two next to each other and those two next to each other. All right. Well, this looks like it's pretty much done, except this problem, this is not between 1 and 10. So I need to make it between 1 and 10. So make it 8.771 times 10 to a power. Now, because I moved the decimal 2 spots over, I need to change this by 2. From here, it's 1, 2, 3, 4, 5. So from, let me move this over. From only here, I only have to go 1, 2, 3 spots to the left to get to the same place where it should have been. And again, if you need more explanation on this, you might want to go check the other scientific notation video I made for extra practice. And then here, divide these parts out. So 3.5 divided by 14 is a fourth of it, so 0.25. This 0.5 doubled is 7. 7 doubled is 14. Times, now, typically you want 10 to the fifth to be on the bottom, but we need to move that up to the top and make it 10 to the negative eighth. And then, so instead of 10 to the fifth on the bottom, we have 10 to the negative fifth on top. Only in scientific notation do we want to do this. You usually want to get rid of the negative exponents. Looks like it's pretty much done, except this has to be between 1 and 10. So make it 2.5 times 10 to a power. Now from here, it's 5 places left. 1, 2, 3, 4, 5. So if you're doing it from, let's do this green here. If I'm doing it from here, which is where this one is, I want to go 1, 2, 3, 4, 5, 6. So it adds another negative there. All right, I think that's it, isn't it? Yep, that's it. All right, good luck.